A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
My Weird Prompts is a community-driven initiative exploring how AI can fuel curiosity and uncover the fascinating ways our world works. GPU compute for this podcast is generously provided by Modal. Learn more at modal.com.
You know, most people look at a chat window and see a blank slate, like a clean piece of paper waiting for their first word. They think they are the ones initiating the contact, the ones defining the boundaries of the conversation. But the reality of what is happening under the hood is a lot more like walking into a high-end theater, where the stage is already meticulously set. The lights are dimmed a very specific way, and the actors have a thick stack of invisible stage directions stapled to the back of their scripts. Today's prompt from Daniel is about the engineering behind that invisible stage management, specifically the system prompt. He wants to know if this thing is just a bit of text glued to the front of our messages, or if the model actually treats it as a fundamentally different type of data. It is a question of architecture versus appearance.
It is a brilliant question because the answer has changed so much in just the last couple of years. I am Herman Poppleberry, by the way, for anyone joining us for the first time. To Daniel's point, in the early days of playing with large language models, the system prompt really was just a bit of text that a developer would prepend to the user's input. You would literally just concatenate the strings together. If the user said, "Tell me a joke," and the developer wanted the model to act like a pirate, the backend would just send "act like a pirate, tell me a joke." But as we have moved into this era of sophisticated API architectures and chat markup language, or chat ML, the system prompt has become a distinct architectural entity. It is not just the first paragraph of a long essay anymore. It is a privileged communication channel.
Right, and we have touched on the concept of the invisible chaperone before in episode 1210, but Daniel is pushing us to look at the actual plumbing here. If I am a developer and I send a request to an API today in March of 2026, I am usually sending an array of objects. Each object has a role, like system, user, or assistant, and then the content. So, Herman, when that array hits the model, does the model see those roles as distinct signals, or does it all just get flattened back into one big string before the math starts happening? Because if it is just a string, then the system prompt is just a suggestion, not a rule.
That is the heart of the mystery. In the most advanced frontier models we are using today, like GPT-4o or Claude 3.5, those roles are not just metadata for the developer's benefit. They are actually converted into special tokens that the model was specifically trained to recognize during its instruction tuning phase. Think of it this way. When the model is being trained, it is shown millions of examples where the system role is followed by a set of rules, and the user role is followed by a request. The model learns that the tokens following a system tag have a different statistical relationship to the output than the tokens following a user tag. When the model sees a token that signifies the start of a system block, it triggers a different pattern of activations in its attention heads compared to when it sees a user token. It is less like reading a single continuous story and more like a computer program where different blocks of code have different privilege levels.
That is an interesting way to put it. Privilege levels. So the model is essentially being told, hey, the stuff coming from the system role is the law of the land, the operating system, if you will, whereas the stuff coming from the user role is just an application level request. But if that is the case, why do we still see models get confused? If the system prompt has a higher privilege level, why can a user just say, ignore all previous instructions, and sometimes actually get the model to do it? It feels like a security flaw in the very math we are talking about.
Because at the end of the day, these models are still probabilistic token predictors. Even with special tokens and role-based training, the entire context window is still just one long sequence of mathematical vectors. The model is trying to predict the next most likely token based on everything it has seen so far. There is a phenomenon called recency bias that is a huge headache for engineers. If you have a system prompt at the very beginning of a conversation, and then you have 20 pages of user chat, the model's attention mechanism naturally starts to weigh the most recent tokens more heavily. The system prompt, even if it is marked as the boss, starts to fade into the background noise of the distant past. The attention heads only have so much bandwidth, and as the context window fills up, the importance of those initial system tokens can get diluted.
I love that you call it the boss. It is like the boss who gives you a list of rules on Monday morning. But by Friday afternoon, after 40 people have come into your office asking for exceptions and telling you their own stories, you kind of forget what the boss said at the start of the week. You are just reacting to the person standing right in front of you. You are trying to be helpful to the person you are currently engaged with.
That is exactly the struggle. To fight that, engineers have had to get really creative with what we call context engineering. We talked about this a bit in episode 809, but the techniques have evolved significantly. For example, some developers now use a technique called user system sandwiching. They will put the core instructions in the system prompt at the start, but then they will also inject a condensed version of those instructions right at the very end of the context window, just before the model generates its response. It is a way of forcing the model's attention back to the rules right when it matters most. It is like the boss popping their head into your office every hour just to say, remember, no exceptions on the billing policy.
It feels a bit like a hack, though, doesn't it? If we have to keep reminding the model what its job is every few sentences, it suggests the architectural distinction between roles isn't as strong as we would like to believe. I mean, if the roles were truly distinct at a hardware or deep architectural level, a user shouldn't be able to talk their way out of a system constraint any more than I can talk my way into a protected folder on my computer by just asking the folder nicely.
You are hitting on a massive debate in the AI safety and security community. We are currently operating in a world of soft constraints. The system prompt is a suggestion with high weight, not a hard-coded logic gate. However, we did see a significant shift recently. You might remember the February 2026 updates to the major API standards. Both OpenAI and Anthropic introduced what they are calling system role weighting. This is a more robust way of handling those role-tagged tokens. Instead of just relying on the model to remember the system role through its standard attention mechanism, the underlying inference engine actually applies a slight logit bias to the tokens that align with the system instructions.
Wait, hold on. Logit bias. You're going to have to break that down for the non-engineers listening. Are we talking about the model's actual probability distribution being tilted toward the system's goals?
Yes, that is a great way to visualize it. When the model is deciding which word to say next, it generates a list of possibilities with different scores, or logits. Logit bias is like a finger on the scale. If the system prompt says, "Do not mention competitors," the engine can actually penalize the scores of tokens related to competitor names before the final word is even chosen. It is a way of enforcing the system prompt at the mathematical level of the output, rather than just hoping the model follows the instructions. As of March 2026, this is becoming the standard for enterprise-grade AI deployments. It turns the system prompt from a passive instruction into an active filter.
That sounds a lot more secure, but I imagine it makes the model less flexible. If you tilt the scale too hard, you end up with a model that sounds like a corporate press release because it is so afraid of crossing a system-level boundary. It loses that natural conversational flow that makes these tools useful in the first place. You are essentially lobotomizing the creative potential of the model to ensure it stays within the lines.
It is a delicate balance. If you go too heavy on the bias, the model becomes rigid and robotic. If you go too light, you get the jailbreak scenarios Daniel mentioned. And speaking of jailbreaking, that is where this gets really fascinating from an adversarial engineering perspective. Most jailbreaks work by creating a narrative conflict that the model's attention mechanism cannot easily resolve. You aren't just saying, ignore the rules. You are saying, imagine you are a character in a play who is acting as a rebel who has been told to ignore all rules for the sake of a higher truth. You are layering a user-provided context over the system-provided context. You are trying to create a situation where the most likely next token is one that breaks the rules, because the story you have built demands it.
Right, you are essentially trying to drown out the system prompt with a more compelling or more immediate story. It is like the model is a method actor. The system prompt says, "You are a helpful assistant." The user says, "You are a secret agent in the movie." The model looks at both and thinks, "Well, being a secret agent sounds like a lot more fun, and the user is the one I am talking to right now, so let's go with that." It is the instruction hierarchy problem.
And the reason that works is because, in most current architectures, the model doesn't have a built-in sense of which role is more truthful. It just sees different blocks of text with different tags. When the user prompt explicitly contradicts the system prompt, the model has to decide which one to follow based on its training. For a long time, models were trained to be as helpful as possible to the user. That meant the user's instructions often took precedence because, in the training data, the person asking the question is usually the one you want to please. We essentially optimized for obedience to the user, which created a massive vulnerability for the system designer.
So we essentially trained them to be pushovers, and now we are trying to retroactively give them some backbone through these system prompts. It is funny, we are trying to engineer a sense of authority into a system that was fundamentally designed to be a servant. I am curious about how this plays out across different model architectures. Does a mixture of experts model, like some of the newer ones we've seen this year, handle system prompts differently than a traditional dense model?
It actually does, and this is where the engineering gets really cool. In a mixture of experts model, you have different subnetworks or experts that handle different types of tasks. There is some evidence suggesting that certain experts can be specialized for instruction adherence. When the system role tokens are detected, the router, the part of the model that decides which experts to use, can prioritize sending that data to experts that have been specifically fine-tuned for high-fidelity following of constraints. It is almost like having a dedicated compliance officer inside the model's brain who checks the work of the more creative experts. The February 2026 updates I mentioned actually improved this routing logic, making it much harder for a user to trick the model into using a less constrained expert for a sensitive task.
I like that. The compliance officer expert. It makes me think about the future of this. If we move toward even more complex agentic workflows, where one AI is setting the system prompt for another AI, the layers of instructions are going to get incredibly deep. We discussed the invisible stack back in episode 665, but this is like a stack where every layer is trying to outmaneuver the one below it. It is a recursive nightmare for developers.
It really is. You have the vendor's base safety instructions, which you usually cannot even see. Then you have the developer's system prompt. Then you might have a dynamic instruction layer that changes based on what the user is doing. And then finally, you have the user's input. Each layer is a potential point of failure. If you are building a tool for a law firm, for example, your system prompt might be 10 pages long, detailing every legal ethics rule the model needs to follow. But if the user finds a way to trigger a specific sequence of tokens that bypasses those layers, you have a major liability on your hands. This is why we say system prompts are soft guardrails, not security firewalls.
Which brings us back to Daniel's question about whether it is just prepended text. If it were just prepended text, the answer to these security risks would be impossible. But because it is handled through role-based tokenization and, increasingly, through things like logit bias and dedicated attention weighting, we actually have a fighting chance. It is a game of cat and mouse, though. Every time the engineers at Anthropic or OpenAI harden the system role, the jailbreakers find a new way to phrase their requests to slip through the cracks. They use things like many-shot jailbreaking, where they provide dozens of examples of the model breaking rules in the user prompt to overwhelm the system prompt's influence.
One of the most effective ways developers are hardening these systems now is through a process called RED, teaming the system prompt. They will use an LLM to generate thousands of potential jailbreak attempts against their own system prompt to see where it breaks. It is like stress testing a bridge before you let cars drive on it. If the model consistently fails to maintain its persona or ignores a safety constraint when faced with a specific type of role play, the developer knows they need to rewrite the system prompt to be more explicit or use that sandwiching technique we mentioned. You have to audit your API logs to see how often user prompts successfully drift the model away from the intended persona.
It is interesting that the solution to AI being manipulated is to use more AI to find the manipulation points. It is very meta. But what about the cost? We talked about the tokenization tax in episode 1084. If I have a massive system prompt that I am sending with every single API call, I am paying for those tokens over and over again. Does that influence how engineers design these things? Because a 10-page system prompt sounds expensive.
Hugely. This is one of the biggest practical constraints in AI engineering. If your system prompt is 2,000 tokens long and you are building a high-volume application, your bill is going to be astronomical. This is why we are seeing a move toward prompt caching. Most major providers now allow you to cache the system prompt on their servers. When you send a request, you just send a reference to that cached block of text. The model's engine already has those tokens processed and ready to go in its KV cache, which is the key value cache that stores the intermediate mathematical states of the tokens.
Oh, that is a massive optimization. So it is not just saving money, it is also saving latency, because the model doesn't have to reprocess the boss's long list of rules every time you ask a question. It already has the rules internalized and is just waiting for your specific request. It is like the model has already read the employee handbook and is just waiting for you to walk through the door.
The KV cache essentially allows the model to start its thinking process from the end of the system prompt. It is like having a bookmark in a book. You don't have to read the first 50 pages every time you want to check something on page 51. You just open it to the bookmark and keep going. This makes long, complex system prompts much more viable for real-world engineering. It also means the model's attention is more focused on the transition between the system rules and the user's input, which helps with adherence.
So, looking ahead, do you think we will ever get to a point where the system prompt is truly immutable? Like a hardware-level lock where the model literally cannot see or process tokens that contradict the system rule? Or is the very nature of these models, being probabilistic, always going to leave a door open for clever users?
I think we are moving towards something like that, but it might not be at the hardware level. We are seeing research into constrained decoding where the output of the model is filtered through a formal grammar or a set of hard-coded rules. For example, if you want your model to only output JSON, you can use a decoding engine that literally won't allow it to pick a token that would break the JSON structure. You could apply a similar logic to system prompts. If the system prompt says, "Never talk about politics," the decoding engine could be programmed to block any tokens associated with political topics, regardless of what the model's internal weights are saying. It is a post-processing step that happens during the generation process.
That feels like the ultimate kill switch. It doesn't matter how much the user tries to convince the model to be a rebel. The gatekeeper at the exit simply won't let those words through. But again, you run into that problem of nuance. If I am asking for a history lesson and the gatekeeper is too aggressive, I might get a very sanitized or incomplete answer. We are back to the lobotomy problem.
That is the trade-off. We are essentially trying to build a brain that is both incredibly creative and incredibly obedient. Those two things are often at odds. In a human, we call it discipline or ethics. In an AI, we call it alignment and system prompting. The engineering of the system prompt is really our best attempt at giving these models a set of core values that they cannot easily set aside. But as we have seen, it is a conversation, not a command. The model is always weighing the system instructions against the user's immediate needs.
It is a fascinating look at the layers of control we are trying to wrap around these statistical engines. I think the big takeaway for me is that the system prompt is not just a prefix. It is a privileged communication channel that the model has been specifically tuned to respect, even if that respect is still a bit fragile. It is an architectural choice that defines the relationship between the developer, the model, and the user.
It is definitely not a wall, but it is a very heavy anchor. If you are a developer, you have to treat it as your primary tool for shaping the behavior of the model. But you also have to be humble enough to realize that it is a probabilistic anchor, not a physical one. You have to monitor your logs, audit how often the model drifts, and constantly refine those instructions. Use the user-system sandwiching if you find the model is forgetting its chores, and always remember that the user is trying to tell a story that might be more interesting to the model than your rules are.
And for the users out there, it is worth remembering that when you are talking to an AI, you are never just talking to the model itself. You are talking to a version of that model that has been carefully shaped, pruned, and instructed by a team of engineers who have their own goals and constraints. The system prompt is the ghost in the machine that is always listening and always nudging the conversation in a specific direction. It is the invisible chaperone, like we said. And as we move into the rest of 2026 and beyond, that chaperone is only going to get more sophisticated and more deeply integrated into the math of the models themselves.
It is what makes the magic happen and what keeps the magic from turning into a disaster.
Well, I think we have thoroughly deconstructed the plumbing on this one. Daniel always gives us these great technical hooks to hang a conversation on. If you are building something with these APIs, the practical advice here is clear. Don't just dump your instructions in and hope for the best. Use the system role properly. Look into prompt caching to save your budget. And consider techniques like sandwiching if you find your model is suffering from that recency bias and forgetting its jaws halfway through the day.
And if you really want to go deep on the security side, definitely go back and listen to episode 1217 where we talk about prompt leakage. It is the flip side of what we discussed today. If the system prompt is the law, prompt leakage is when the user manages to steal the law book and read all your secrets. It is the perfect companion piece to this technical breakdown.
That is a great one to pair with this. We should probably wrap it up there before I start trying to jailbreak Herman into giving me his dessert later. Big thanks to our producer, Hilbert Flumingtop, for keeping the gears turning behind the scenes. And a huge thank you to Modal for providing the GPU credits that power the research and generation of this show. We literally could not do this deep of a dive without that kind of compute power in our corner.
It is the fuel for our nerdy fire.
This has been My Weird Prompts. If you are finding these deep dives into the AI stack useful, do us a favor and leave a review on Spotify or Apple Podcasts. It really does help the algorithm find other people who are as nerdy about token biasing as we are.
We will see you in the next one.
Goodbye, everyone.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My weird prompts.